Hello students, how are you doing? I hope you're doing fine. In the last lecture, we have covered the topics like rate of reaction, rate law, factors affecting rate of reaction, order and molecularity. And today in this lecture, we'll try to cover up these topics: methods to find order of reaction, temperature coefficient, catalyst, collision theory and Arrhenius concept. These are very important topics. So please pay attention, stay connected, don't lose the focus and keep on practicing the questions. Okay, so we'll begin with the first topic, that is methods to find order of reaction. Okay students, let's come and study the methods to find the order of reaction. The first method is graphical method. So in Neet, what they give a question based on graphs and they ask you which order this graph belongs to. So how you will do that? Let's learn that. I'm taking a simple example, A giving you products where A is a reactant and rate law is like R equals to K, A to the power of M. Since I do not know the order, so I'm putting it M. Now we'll study the different orders one by one. For zero order reaction, we know that rate is independent of concentration of reactant. So this will be R will be equal to K. Now we have to plot graphs with R on the y-axis and concentration on the x-axis. Since this is independent of concentration, it will be a straight line parallel to concentration or the x-axis. So whenever you see this kind of graph, you can 100% say that this graph belongs to a zero order reaction. Now coming to first order, R will be equal to K, A to the power of 1. Now if I put A here on the x-axis, this equation is y equal to mx. So this is the equation of a straight line where R is on the y-axis and A is on the x-axis. So slope will be K for this straight line. Now coming to the second order, I am again doing what? I am taking R equal to K A square. Now on the x-axis I have put A square. Now this will be an equation of straight line if I put A square on the x-axis. So again a straight line passing through origin. But remember that if they give you A and they give a parabola, this equation is also an equation of parabola only if we have got A concentration to the power of 1 on the x-axis, then this is the parabola. Otherwise it will be a straight line if I have got A square. So please keep on looking what is given on the x-axis. Okay, now in general for any nth order, what we can do, R will be equal to K, A to the power of M. If on the x-axis I take A to the power of M, then this also becomes the equation of a straight line passing through origin. So in general what I'm trying to say that if on the x-axis they have given A to the power of M, M may be 1, 2, 3, whatever it may be, and rate is given on the y-axis. If you are getting a straight line, that will be the reaction of mth order. Okay. So students, the second method to find out the order of reaction is initial rate law method. So in this method, what they will give you in the examination hall, they will give you a reaction. And suppose the rate law for this reaction can be written as R equals to K, A to the power of M and B to the power of N, where M and N are the order of reaction with respect to A and B respectively. So what you will do in this question, you first of all do one thing, keep concentration of B constant. Once the concentration of B is constant, K is already a constant, so rate will be proportional to A to the power of M. So I can say that R2 by R1 will be equal to A2 by A1 to the power of M. Here rate is proportional to concentration of A only. Now in the second section, you keep the concentration of A constant. Now the rate will be proportional to concentration of B only. So I can say that R2 by R1 will be equal to B2 by B1 to the power of M. This will be N, since the order is N actually. Now how you will handle the questions based on this aspect? So this is the category of question which they give in Neet. Here they will give you 3 experiments. They will change the concentration of A and B and they will give you the rates when they are changing A and B. So to do these questions, do one thing again, just like this, choose any 2 readings where the concentration of A or concentration of B is constant. If concentration of A is constant, the rate will be proportional to B and vice versa. So I'll take first 2 readings. So in these 2 readings, you can see that concentration of A is changing, but concentration of B is fixed, same, constant. So I can say that R2 by R1 will be equal to A2 by A1 to the power of m. I'm assuming that the order of A is m. So R2 will be 8, R1 is 2. So 8 by 2 will be equal to concentration of A2 is 2, concentration of A1 1 to the power of m. So solve it. This will be 4 equals to 2 to the power of m. This 4 can be written as 2 square. That means 2 to the power of m. Now once the base is same, we can equate the power also. So from here I can say that m will be equal to 2. So order of reaction with respect to A will be 2. Similarly, if I take, you can take 1 and 3 now. You can take 1 and 3. Here the concentration of A is constant, but the concentration of B is changing. So with experiment number 1 and 3, I can say that R2 by R1 will be equal to concentration of B2 upon concentration of B1 to the power of n. R2 will be 16, R1 will be 2, should be equal to B2. B2 will be 10, B1 will be 5 to the power of n. Solve it, it will be 8 equals to, this will be 2 to the power of n. This 8 can be written as 2 cube equal to 2 to the power of n. Now once the base is same, we can equate the powers. So here I can say that n is equal to 3. So order of reaction with respect to B is 3. Order of reaction with respect to A is 2. Overall order, if they ask you what that will be summation of m and n. 2 plus 3. Overall order will be 5. Okay. I hope now the things are becoming clear with respect to the initial rate law method. We shall solve a couple of more questions to make sure that there is no doubt remaining inside your head. So the question number 1, they have given you rate law R1 equals to K into A into B to the power of 1 by 2. So here the order of reaction with respect to A is 1, with respect to B is half. Now they are saying that if A and B concentration are made 4 times each, find the new rate. Now see, I know the rate law. So R2 will be K into, make the concentration of A and B 4 times. Let the initial concentration of A be A. So new concentration will be 4A and that of B will be 4B to the power of 1 by 2. Now simplify that. Take out from 4 from here. This will be 4 into A, and take out square root of 4 from here. That will be 2, and that will be B to the power of 1 by 2. This can be written as 4 into 2. That will be 8. 8 into K A B to the power of 1 by 2. Now what is this? This is nothing but R1. So R2 will be 8 into R1. That means the final rate or the new rate will be 8 times of the initial rate, just because we have changed the concentration. We know that rate can be changed by changing concentration. Now let's come to the second problem. This problem says A is giving you product. So A is a reactant. Only one reactant is there. If concentration of A is made 4 times, the rate doubles. The rate is doubling. Find the order of reaction. Now I know that since there is only one reactant, R will be K A to the power of M. I do not know the order which is I'm supposed to calculate. So R2 by R1, we have just done that, will be equal to concentration of A 2 upon concentration of A1 to the power of M, where M is the order of reaction. Now they are saying the rate doubles. So R2 by R1 I can write as 2 will be equal to A2 by A1. They are saying the concentration of A is made 4 times. So A2 by A1 will be 4 to the power of M. Simplify that. This is 2 to the power of 1. This will be 2 square to the power of M. This can be written as 2 to the power of 2m. Now once the base is same, power can be equated. That means 1 will be equal to 2m, or I can say m will be equal to half. So order of reaction with respect to A will be half. I hope this is clear. Okay. Students, so we are on to a very important question, and this question the Neet has been asking multiple times. This question is a question based on mechanism. So what they will give you in this question, they will give you a complex reaction and they will also provide you the mechanism. All the steps of mechanism are elementary reactions. This is one elementary reaction, this is a second elementary reaction. So you will have to write down the rate law. In this question we have to find out the rate law. How you will solve that? Learn this method. I mean, this is the fixed method of solving these questions. So let me explain you. So in these questions, first of all, go to the slow step. This mechanism will contain some steps which will be fast one and one step will be slow. You focus on the slow step, that is the RDS. Write down the rate law for the slowest step. So I'll write down the rate law for the second reaction. So rate law will be K3 O3 into O. So fine. But see, this rate law is useless for me. The reason being, it contains a term called O. This O is not the part of the original equation, the final equation. O is the intermediate. It is formed during the course of reaction and it is consumed before the end of reaction. Now the problem with the intermediates is that I will never be able to tell with definite or say 100% surety what will be the concentration of A. So the problem with the intermediate is that I will never be able to calculate the concentration of intermediate with certainty because they are consumed within the course of reaction. Okay, so how you will make it meaningful? You will make it meaningful by deleting the intermediate. How you will delete this intermediate? You will have to go to the previous equation always. First focus on the slowest step. Write down the rate law. In the slowest step, you will always find one of the intermediate whose concentration will be almost impossible to calculate. So to get rid of this intermediate, we will have to go back to the first equation, the previous equation, which will always be a fast reaction. So, and this reaction will also be in equilibrium. So this is basically my third equation. Now from first, which is basically in equilibrium. You can see that this equation is in equilibrium. I can say that rate of forward reaction is equal to rate of backward reaction. So what is rate of forward reaction? Let's come over here. Rate of forward reaction will depend on the concentration of ozone and K1. So I can write down rate of forward reaction will be K1 O3 should be equal to, since this is an equilibrium, so backward reaction will be dependent on concentration of O2, concentration of O and K2. So this will be K2 into O2 and O. So from here I can say that O will be what? K1 upon K2, O3 and O2. So this is my say fourth equation. So from here I can put or replace the value of O here. So from third and fourth I can say that rate will be what? K3 into O3 into O. What is the value of O? The value of A is K1 by K2 O3 by O2. Now simplify that. This will be K1 K3 upon K2 and into O3 whole square, and this is divided by O2. So I can take it up and make it O2 inverse. So I can write down that this will be K1 K3 upon K2 into O3 whole square and O2 inverse. So this is the final rate law. Now this rate law does not contain any intermediate. This contains reactant and product, and you can see that we have an order which is negative. So if they ask you what is the overall order, it will be 2 minus 1 1. So this is how you are going to solve the questions of mechanism. How you will do that? I'll just revise it for you. Go for the slowest reaction, write down the rate law for that. This rate law will always contain an intermediate. To remove that intermediate, you have to always go to the previous equation, which will always be a fast reaction, and also this will be a equation in equilibrium where the rate of forward will be equal to rate of backward reaction. So by equating them, you get rid of this intermediate. Now when you will get the value of this intermediate, you put this value in the first equation. You will get final rate law which will not contain any intermediate. Okay, I hope this is clear. Okay. So after doing the questions on how the rate will change on changing concentration, let us focus now on how rate will change on changing temperature. While discussing the rate law, we came to know that in that rate law, if I keep the concentration constant, but if I change temperature, rate constant will change, and because of that rate will also change, rate of reaction will also change. So the scientists who were working on this aspect, how the rate will be affected if we change temperature, they came to conclusion that for certain reactions, on increasing the temperature by 10 degrees Celsius every time, they found that the rate either doubled or tripled, or it stayed between doubling and tripling of the rate of reaction. So since they knew that the rate is changing because of what? Change in rate constant. So we can say that for certain reaction, on increasing the temperature by 10 degrees Celsius, the rate constant will either double or triple, or will stay between doubling and tripling. So depending on whether this is 2 or 3, generally they give you questions on 2. The rate, the temperature coefficient being 2. They might also give you a question when temperature coefficient is 3. So for both of the cases, we have these two formulas. K2 equals to K1 into 2 to the power of T2 minus T1 divided by 10. If the temperature coefficient is given as 2. If it is given as 3, in place of 2, replace 3. Now let us do a question on that. So find K2 by K1 if temperature changes from 20 degrees Celsius to 50 degrees Celsius. Now remember, if they do not provide you any other information, you have to assume that the temperature coefficient is 2. So from this formula, I can say that K2 by K1 will be 2 to the power of T2 minus T1 divided by 10. So this can be written as 2. Temperature T2 is 50. 50 minus 20 divided by 10. This will be 2 to the power of 3. That means this K2 by K1 will be 8 times. That means rate will increase by 8 times if we assume that the temperature coefficient is given as 2. Similarly, if they give you the fact that the temperature coefficient is 3. So in place of 2, you just write down 3. So I can say that K2 by K1 will be 3 into 3 to the power of, now 50 minus 20 divided by 10. So this will be 3 to the power of 3. That means K2 by K1 will be 27, or I can say that rate will increase by 27 times if the temperature coefficient is given as 3. I hope it is clear now. Okay students, while discussing the factors affecting the rate of reaction, we came across one factor called catalyst. So let us check out whether we have understood the catalyst properly or not with the help of this question. This question says, which of the following are true for catalyst? So the first sentence, the catalyst can take part in reaction. Is it true or false? See, many students think that the catalyst cannot take part in a reaction. It can take part in a reaction. Okay, remember, this is true. This is true. It can take part in a reaction, and while taking part in a reaction, it is quite possible. It is quite possible that its physical state might change. So, for example, if I take a solid piece of a catalyst, at the end of the reaction, I will end up having the powdery form of the catalyst. So its physical form might change because it has taken part in the chemical reaction. So the second part is also correct. Its physical state may change if it participates in a reaction. It is not as if catalyst will always participate actively in a reaction. Okay. it changes the rate constant. Yes, we know that in the rate law we came across that R will be K A to the power of M. So rate law tells how a rate of reaction will depend on the concentration and the other factors. All these other factors were included in K. So catalyst, if I am using, the rate constant will change. So it changes the rate constant. Yes, definitely it changes the rate constant. It can change delta G, delta H, delta S entropy of a reaction. Remember that, student, chemical kinetics has got nothing to do with thermodynamics. Whatever is in thermodynamics, it cannot be changed by changing kinetics. So catalyst, it affects only kinetics, it does not affect thermodynamics. So delta G, delta H and delta S of a reaction does not change at all. So this is incorrect. It cannot change anything which is of thermodynamic nature. Now again, the fifth sentence, it changes position of equilibrium. Again, equilibrium is a thermodynamic property. Anything which is kinetic has got nothing to do with something thermodynamics. So it does not changes equilibrium. This is also wrong. Okay, I mean these two sentences, they just say that these are all thermodynamic terms. Thermodynamic terms cannot be changed by using catalyst. It will increase the amount of product. Now the amount of product, how much of this will be produced, it is again a property of thermodynamics. It is again a property of delta G, how much of the product will be formed. I told you in the beginning that thermodynamics decides how far the reaction will go, how much of product will be formed. This is thermodynamics again and not kinetics. So it will not change the amount of product, only it will change the time required to form the product. Suppose you are getting 10 moles during a course of a reaction before using catalyst. After using catalyst, you will again get 10 moles, but this time you will get them quickly because the catalyst, it shortens the time of reaction. Next one, it lowers the energy of activation. Yes, it is correct because it enhances the rate of reaction by lowering the energy of activation. So remember that, guys. I mean these points, and out of that 4, 5 and 6 point, they are all thermodynamic in nature, and catalyst does not change anything which is thermodynamic. One more thing, it changes rate constant because in rate law we came to know that this rate constant, it depends on temperature, catalyst, all other factors except concentration. So rate constant depends on all the factors except concentration. Remember that, okay? I hope it is clear. So students, I mean if you have been revising the things properly, you are following the instructions, there is nothing which can stop you. I can very well understand that staying home and having nothing else to do might be sometimes boring, but you can take this as an opportunity for the fact that you have got a greater time now to prepare for your entrance examination. Now we are into a very good position as far as chemical kinetics is concerned, and we have reached a point where we will discuss that for every successful reaction there will be two barriers against it. One is the energy barrier and second one is the orientation barrier. Someone has correctly said that science is a great teacher. It's the best place to learn something about life. Just as for a successful reaction to occur, these two barriers, energy barrier and orientation barrier, should be crossed. Similarly, in life, for you people to become a successful candidate, you should also cross the energy barrier and the orientation barrier. There are certain students who are lacking energy. They are completely not focused into the studies. They are not energetic while doing the studies. They might face some problems. There are students who are having energy, but they are not properly utilizing that. That means they are not in the right orientation. They simply do not know how to study, what to study, and they exactly do not know how to crack the entrance examination. That is the orientation barrier. So if you really want to become successful, you have to cross these two barriers. And collision theory exactly says the same thing, that if you want to go for a successful reaction, we have to cross these two barriers. So collision theory, it is basically based on kinetic theory of gases. They ask you a kind of a question from collision theory, which of the following is correct or incorrect. Okay, so it is based on kinetic theory of gases. Very important point. It is valid for bimolecular reactions. It is valid for bimolecular reaction, and also the particles, they must collide. Collision theory says that in order to have a successful reaction, first the two particles should collide, and not only they should collide, they should also have sufficient energy, which is called energy of activation, the minimum amount of energy required to cross the barrier. Now they should also have, apart from having sufficient energy, a proper orientation. Without proper orientation, the particles will not be able to do a successful reaction. Let's take an example kind of thing. Say for example, we have to climb this mountain to reach this castle, and to reach this castle, there is a window out here, and you can enter this castle from this window. Now if you really want to reach this window, first of all you should have energy sufficient enough to make you reach here. What I am trying to say is that if you don't have sufficient energy, you will be here or here but not reaching the destination. Also, if you are trying to jump from here or here, you will never be able to go there, because that's the only window, so you have to come from this way. So orientation is also important apart from energy. Both these factors are very important, and these two factors are literally highlighted by collision theory. Now let us see the mathematical format of that. So for that we have to go through Arrhenius equation. Let's do that. Theory basically is a theoretical discussion of energy barrier and the orientation barrier. We need a mathematical discussion to handle the questions. So this mathematical aspect of collision theory was given by Arrhenius. So he came up with a mathematical equation which said that rate constant is equal to a constant, e to the power of minus of Ea. Ea is energy of activation divided by RT. So here there are two terms, A and this exponential term. This A is called orientation barrier, and this exponential form is called energy barrier. Now this A is also called Arrhenius constant or pre-exponential factor, because it is coming before exponent. This factor e to the power of minus of Ea upon RT take care of the fact that how many fraction of particles are having energy which is more than energy of activation. So this factor A tells you that how many particles are having right orientation. This second fraction, or second thing, tells you how many particles are having energy more than energy of activation. So we all know that as I increase temperature, rate constant will increase. So what is the meaning of this? If I keep on increasing temperature, the rate constant will keep on increasing infinitely. I mean to say that as temperature approaches infinity, will the maximum value of K will also be infinity? No, it will not be infinity. Let us check it out. So from this equation, K equals to A e to the power of minus of Ea by R. If you put temperature as infinity, so this is something divided by Ea divided by infinity will be 0. So you can say that K will be A to the power of e to the power of minus of 0, which is nothing but 1. This thing will be 1. So K will be equal to A. That means if I increase the temperature to infinity, the maximum value of K which can be achieved is A, not more than that. So this is the maximum value of K. Maximum value of K. What is the maximum value of K? It is A, the pre-exponential factor or Arrhenius constant. Also remember that since this thing is a pure number, so it is unitless. So I can say from here that unit of K will also be the unit of A. So very important point to note that unit of K is equal to unit of A. Both A and K will have same units. I hope you got that. Okay. Now Arrhenius equation is a very important equation. Many a times Neet has been asking question from this topic also. So what kind of question they will be asking? To understand that, let us understand the modifications of this Arrhenius equation. K equals to A e to the power of minus of Ea by RT. So this equation tells you with confidence that rate constant can be changed by changing temperature. Now if we take natural logarithm of these things, I'll get this equation, okay, and if I plot a graph with log of k, natural log of k on y-axis and 1 by t on the x-axis. Remember that this is 1 by t and not t. So if they give you a graph with t on this x-axis, this will definitely not be the line. To get a straight line like this, this has to be 1 by t, whose slope will be minus of Ea by r. And if I convert this natural log into log to the base of 10, in that case everything remains same, only the slope will change from minus of Ea by r to minus of Ea by 2.303 r. Okay, now let us see what is the relationship between the rate constant if we change temperature with certainty. Earlier we saw that there was a rudimentary concept called temperature coefficient, which was valid only for certain reactions and for certain range of temperature. But here we can find out the different rate constant at different temperatures from this equation. Okay, so remember, this is a very important equation. So let us do some questions on that. Okay, let's solve some questions based on Arrhenius equation. They have given for a first order reaction, this is the equation given, and they're asking find A and energy of activation. This is pre-exponential factor. Now see, I know the logarithmic form of Arrhenius equation, so let me write down. That is basically log of k equals to log of A minus of Ea upon 2.303 r into 1 by t. So if I'll compare these two equations, I'll come to know that this 6 is nothing but log of A and this 2000 is nothing but Ea upon 2.303 r. So let us solve that. Log of A is equals to 6. This is base 10 actually. So if I take anti-log, I'll get A equal to 10 to power of 6. Now regarding the units of A, now we have discussed that the unit of K is also the unit of K. Now for the first order reaction, we have already done that the unit of K is what? Per second. So its unit will be per second. Remember that unit of K is very important, and for first order reaction unit of K is per second. Unit of K is also the unit of A also. Now come to second part, Ea. Now Ea upon 2.303 r will be equal to 2000. So Ea will be equal to 2.303 into R will be say 8.314 if you want answer in joule or kilojoule into 2000. So when you will solve that, you will get approximately 40 kilojoule as your answer. So this is the methodology how you are going to solve these kind of question. Now let us come to this question. It says that rate of reaction doubles on increasing temperature from 300 Kelvin to 310 Kelvin. Find energy of activation in that case. Now let's say that rate law is R equals to K A to the power of M. I do not know which order this reaction belongs to, but let it be like M. Now I know that on increasing temperature rate will increase, and change in temperature will affect what? Rate constant and not concentration. So on increasing temperature both rate and rate constant will change. So I can say this is the R2, this is K2, and we are not disturbing concentration because concentration will remain constant. I'm not changing concentration. I'm simply changing temperature, which will result in the change in rate constant. And again R1 will be given by K1 into A to the power of M. If I take a ratio of these two, the concentration term will disappear, and I'll come to know that R2 by R1 is equal to K2 by K1, and they have given that the rate of reaction doubles. So R2 by R1 is given as 2. So I can say that K2 by K1, which is also R2 by R1, will be equal to what? 2. Now I know only one equation when they give two different temperature, and that is what? Log of K2 by K1 is equal to Ea upon 2.303 R 1 upon T1 minus 1 upon T2. Now put the values. This will be log of 2 from here. Energy of activation. If I am taking R as 8.314 in joules. This will be approximately 20, and this will be 310 minus 300 upon 300 into 310. Now, when you will solve that, you will get EA equals to 54 kilojoule. This is how we are going to solve the question like this, okay?